Hi, geometry. Our last lesson in trig is going to be the law of cosines, and we're going to focus on word problems today. This is the note packet you'll need to go through the lesson with me. So because these are word problems, we're going to want to draw a picture with each scenario. So this time we have a triangular garden with dimensions of 54 feet, 48 feet, and 62 feet. They want us to find the angles at each corner of the garden. So we need to find all three. So here's my picture. I did label the angles theta, theta sub 2, and theta sub 3. But when we solve the problems, I'm just going to use angle A, angle B, and angle C so that it's less confusing. So with the law of cosines, we need 3 sides and 1 missing angle. So we're going to find angle A first. So what I want to do is start with the side across from it, 48 squared. And then it will equal the other 2 sides, 54 squared and 62 squared. In the center, we're going to use those same 2 values again, so minus 2, and then it's times 54 and 62, and then cosine of A, which is missing. So I'm going to slowly go through each of these problems, pieces and parts. Remember, you can stop the video at any time if you want to try to solve it before me. So moving forward, when I square each of the pieces and then multiply inside, these are the values that result. Remember, don't do too much at one time. I'm going to add the 2916 and the 3844. We are not including 6696. That belongs to cosine of A. Okay, so there we've got the sum. And again, because the 6696 and cosine of A, this is a multiplication problem, I'm going to subtract 6760 from both sides so that the coefficients are together. And this is my result. And now I'm going to divide both sides by negative 6696 to isolate cosine of A. When I put it into the iPad, it did reduce it for me, and 2 negatives are a positive. And then when we're finding a missing angle measure, we're going to use our inverse cosine. And we're going to switch A and the ratio. Make sure that you're in degree mode before you finish your calculation. But the calculator returns for me about 48 degrees when it's rounded. Now that I found the first angle, you can pick either of the other 2 angles to find, but we're going to use the same process. So we're going to pick, for the next example, at least I did, I'm going to find angle B. So really, a lot of this is the same. I just need to start with the side across from angle B, and you can see that that's 62. So one of these sides is different and one is the same, but the process is still the same. So for minus 2, I'm multiplying by 54 and 48, which are the 2 inner pieces, and then cosine of B is on the end. So again, small pieces at a time, I'm going to do all my squaring and my multiplication here. I'm going to combine these 2 values, these 2 coefficients, and then I'm going to subtract 5,220. And then now I can divide by negative 5,184. And again, the calculator did reduce that ratio for me. And we'll activate our inverse cosine. And ultimately, it tells me that angle B is about 75 degrees. I rounded both degree measures to the nearest whole. Now that I know both of those angle measures, finding angle C is just simple math. We'll use the triangle angle sum theorem. So I'm just showing the subtraction of 180 minus 75 and minus 48. So my last angle is 57 degrees. For our next example, number 2, this time we have a parallelogram. It has a 68-degree angle, and it has side lengths of 8 and 12. They want us to find the lengths of the diagonals. I'm going to start with 1. We know with the parallelogram, we have opposite sides congruent. So I've labeled the 8 and the 12 and the 68. I'm looking for the length of this diagonal. You can call it any variable that you want. The parallelogram wasn't labeled. So that's 3 sides and 1 angle. I'm going to simply call it side A. So since that's missing and that's what I'm after, I'll start with A squared. But now I'm going to add in the 8 squared and the 12 squared. And you can see we're ending with cosine of 68, which is across from that missing side. So I'm going to go through and do some of the calculations. I am going to add together the 64 and the 144, and then in a separate piece, I'm going to multiply 192 and cosine of 68. If you find any mistakes in my calculations, just let me know. So now I'm going to subtract, and then I want the square root. And since it's not an exact value, I'm going to round it off to the nearest tenths. So this first diagonal in pink is 11.7. But now I have to find the other diagonal. So I'm going to modify my drawing. I added in the green diagonal. We also need the missing angle measure for this angle up in the corner. Remember, any two consecutive interior angles of a parallelogram must add up to 180. So I know that this angle is 112 degrees. And then I'm going to set it up exactly the same way. So the green diagonal is what I'm looking for. I'm still going to call that side A. I'm still able to use the 8 and the 12 and this multiplication in here. The only thing that's changed is the cosine of 112. So let's go through and do our squaring and our multiplication. We'll combine our like terms. Here's where I'm going to tell you to be very careful. This is minus 192, but when you type in cosine of 112, that value is also negative. So it's minus a negative, which is adding. Don't drop a sign. And now I'm going to square root. And my missing diagonal in green is about 16.7. In example 3, we have an airplane sighted from two locations, and its position forms an acute triangle with them. So I'm going to draw my diagram. It says the distance to the airplane is 20 miles from one location with an angle of elevation of 48. So here's my airplane up in the sky. From this location down on the left, it's 20 miles. Angle of elevation is always on the ground while you look up. And it's 40 miles from the other location. So here's the other location, 40 miles, and the angle of elevation is 21.8. How far apart are the two locations? I have used a lowercase x as it's across from angle x, which is where the plane is located. So again, I have three sides, and I actually have two angles. And couldn't I find the third angle? We could actually use the law of sines here, which is easier than the law of cosines. So let's find the measure of angle x. If I subtract off the two pieces that I do know, that means that angle x is 110.2 degrees. So let's set up the law of sines. I have sine of 110.2 over x because they're across from each other. And then sine of 21.8 is over 20. You could have also used sine of 48 over 40, you'll get the same answer. We're going to cross multiply. And then I'm going to divide both sides by sine of 21.8 to isolate my x. And I get 51, and actually it's not degrees, it should be 51 miles. Our last example, number 4, we have a ranger tower at point A. It is directly north of a ranger tower at point B. And then we have a fire spotted at C, and they can see that fire from both towers. So the distance from fire tower A to the fire is 60. So you can see I've labeled, I did make fire tower A directly north, but you can draw a regular triangle. 60 miles to the fire, and then the other distance is 50 miles to the fire. They're telling me angle ACB is 62 degrees, and I did label that. Find the distance between the two towers A and B. I'm calling that side C. So I do have to use the law of cosines here. I have three sides and one angle. So I'm starting with C squared. I'm filling in the two sides I do know. Again, the same two sides. And then I have cosine of 62. We're going to do our squaring and multiplying. I'm going to combine my like terms, but I'm also going to multiply 6,000 times cosine of 62. Now we'll subtract and we'll square root. So the distance between the two towers is 57.3 miles. This is homework number 107. It does say law of sines and cosines word problems at the top. Please make sure as you finish assignments that you're sending to me by text or email so that I can get them marked in the gradebook. And if you have questions during note taking or homework problems, please text me or call me or send me an email. Have a great day.